Morning dear students, welcome back. So this is the next video on physics of animation. In the previous video I was talking about odd rule and odd rule multiplier. Now come we will discuss about odd rule scenarios. There are totally 4 scenarios as per the syllabus that we have to discuss. Number 1, slow out process. Number 2, slow in process. Number 3, jump up process. Number 4, jump down process. See, in these 4 scenarios we are going to calculate distance between two successive frames as well as the total distance traveled with the help of odd rule. Okay, so in odd rule, remember we must know the base distance. What is the base distance? It is the distance between the smallest distance between the two frames. In case of slow out process, it is the first 2 frames, whereas in case of slow in process, it is the last 2 frames. I hope you already know all these things, so no need of revising all those things. Just you see the previous videos if you want to have first hand information of slow in, slow out, base distance, odd rule multiplier, etc. Come, we shall proceed further. Now comes the first process, that is slow out scenario. Remember I am talking about odd rule scenario. You can expect this for 10 marks or 8 marks. 4 processes I will discuss. Slow out process. Dear students, I take one car moving with increase in the velocity. That means the car is getting accelerated. So that is nothing but slow out process. Initially car is here, so this is my first frame, and gradually its spacing increases. This is my second frame, next this is my third frame, and this is my fourth frame, and so on. You can even have fifth frame also. For the sake of explanation, I take only 4 frames. Okay, let me put one more frame, that is the fifth frame. But dear students, remember this gap is, okay, let me write it properly. The spacing is not uniform here. As you all know, spacing keeps on increasing. Okay, spacing keeps on increasing in terms of odd numbers. So this spacing is the spacing between second and third and fourth is this much, fourth and fifth is this much. Okay, 1 2 3 4 5 like this. Well, assume that the total distance traveled is 2 meter. So total distance traveled is 2 meter. Now comes the explanation of calculations. What is slow out process? It is a process in which the distance is increasing, the body is getting accelerated, speeding up. Okay, this is the base distance and this is the total distance, and there are totally how many frames? Yes, there are 5 frames. Now let us calculate the base distance. Base distance, okay, here onwards I use this symbol B for base distance. I hope you know already the notations I used. A for total number of frames, B for distance between two successive frames. It can be between 1 and 2, 2 and 3, 3 and 4, 4 and 5, and C for distance between first and the present frame. It may be from 1 and 2, 1 and 3, 1 and 4, 1 and 5 like that. Okay, so small b is base distance. By definition, it is the total distance divided by last frame minus 1 whole square. Okay, so that is equal to total distance is 2 meter divided totally how many frames are there? 5 frames are there. 5 minus 1 whole square, that is equal to 2 divided by 5 minus 1 is 4. So 4 square means 2 divided by 4 square, that is 2 divided by 16. Okay, 2 divided by 16, that is 2 ones are 2, 8s are 1 by 8, that is equal to 0.125 meter. Please check this. Okay, so 8 5s are 40, 8 2s are 16 plus 4, 20, 8 ones are 8 plus 2, 1. Correct. So it is 0.125. This you can do using calculator. I just verified because I am not using calculator here. I just verified it. Okay. I know base distance. Okay. Now what is the distance between 1 and 2? From 1 and 2 distance, I should write distance between F1 and F2. That is equal to base distance 0.125 multiplied by 1 that is equal to 0.125. Next, distance between F2 and F3 is equal to base distance multiplied by what number? This is odd rule, multiplied by 3. So here to here it is 1, here to here it is 3, here to here it is 5, here to here it is 7. I hope you got it. So 3. So multiply 3 5s are 7, 0.375. Got it? Next, distance between F3 and F4 is 0.125 into what? It is 5. This is odd rule. Okay, simplify. 0.625. Let me check. 5 5s are 25. Okay, 0.625. Now I am here. Let me calculate the last one. That is F4 and F5. That is equal to 0.125 into what? It is 7. That is equal to 0.875. You got it? Now what is the total distance? It is the distance from here to here plus this plus this plus this. That means I have to add all these things. Total distance calculated. Please calculate. 5 plus 5 plus 5 plus 5. 0, 2 carry. You can use calculator and verify this. Again 2 carry. Yes, I got it. 2. Please check this. So what is this? This is the total distance which I write as C, that is 2 meter. You just cross verify this using the formula. C is equal to A minus 1 whole square. Okay, that is equal to A is, of course, into base distance. A minus 1 whole square into base distance. A is 5. Okay, frame number minus 1 whole square into base distance is 0.125. That is 5 minus 1 whole square means 4 square. That is 16 into 0.125. Please check. You will get the answer as 2 meter. This is the calculation. I hope you got it. This is the scenario number 1 in which I calculated the total distance, frame to frame distance as well as base distance, and cross verified the total distance for slow out process. Dear students, you got it? No? I hope you got it. Now let me move on to second scenario where I have slow in process. Slow in process is just opposite. Initially I have a frame here. Okay, later on here more spacing. Later on the spacing keeps decreasing. Okay, just for the sake of calculation purpose, I take only 4 frames. Right? You can take any number of frames. It is not a big issue at all. Okay, this is my frame number 4, 3, 2, 1, and assume that the total distance traveled is 0.9 meter. It can be anything. I just take simple example, that's all. We can change the values and do the calculations in numerical problem section. Dear students, after all I complete this animation chapter, I take up the model question paper discussion, and also I will solve numericals from module 5, module 3, module 2, even superconductivity also, because many students are requesting me for doing numerical problems on all the modules. That I will take up. Definitely I will take up. I assure you that by first week of April I will complete the entire portion whatever is required for you from the point of examination. Okay, there are 2 model question papers. I will try to solve them also. Okay, back to this. As usual, what I should do, I must calculate base distance. It is equal to total distance. I will not write the formula straight away. I use this equation. Right, total distance is 0.9 divided by last frame is 4 minus 1 whole square. Dear students, please simplify. 0.9 by 3 square, that is 0.9 by 9. It is equal to 0.1 meter. Assume that it is in meter. You can change the unit. It can be inch also, centimeter also, but for the sake of simplification, I take it as meter only. Okay, B is now ready, 0.1 meter. Now I find out the distance between 4 and 3. So F4 and F3 is equal to what? Okay, now what? How many gaps are there? 3 gaps are there. From here it is 1 to 2, 1, 2 to 3, 3, 3 to 4, 5. So this gap I should multiply by 5. This I should multiply by 3. This I should multiply by 1. This is nothing but odd rule, dear students. Okay, so that is equal to base distance 0.1 into 3. Okay, so just this process is reversed, that's all, is equal to 0.3. Next, 3 to 2, I want the distance between F3 and F2, that is equal to 0.1 into 3. Sorry, I made a mistake here. It is actually 5. Sorry, this is 5 because 4 to 3 alva 5. So 5 into 0.1 is 0.5. Now it is 0.1 into 3. This one I have to take, that is 0.3. Now coming to the last one, F2 and F1, that is equal to 0.1 into 1, that is 0.1. Okay, now total it 5 plus 3 plus 1 is nothing but 0.9 meter. This is the total distance traveled. Understood? And you can cross verify this exactly like how I did. C is equal to A minus 1 whole square into base distance. A is totally 4. 4 minus 1 whole square into 0.1, that is nothing but 0.9 meter. Okay, this is scenario number 2. I hope you are following. Now coming to scenario number 3, that is jump up process. Scenario number 3, jump up process. Okay, initially, as I told in my previous video, jumping up or walking, all these things actually comes under non-uniform motion, where the body is subjected to variable force. But I still divide the whole event into several segments or small segments. The force applied is assumed to be constant and acceleration is assumed to be constant. One girl starting from the first position to the last position. Okay, that jumping event I will explain once again later on. Now the whole event, whole process of jumping, I divide into 4 parts. Initially, that girl is in this position. This is first frame F1. Next will be like this F2. Next will be like this F3. I just take 4 frames. Okay, you can take any number of frames, it is not an issue. Just for the sake of explanation, I am taking 4 frames. Dear students, don't think that the frames are equi-spaced. It is not equally spaced. Just for the sake of explanation, I wrote it like this, and because there is no enough space, I wrote it like this. But please remember, frame to frame distance is not at all same. If it is same, what type of motion it is? Sir, it is linear motion, uniform motion, sir. Yes, it is uniform motion where there is no acceleration. Here there is acceleration, so it is linear but non-uniform motion. Therefore, spacing is not uniform. I am telling again and again because you must see the physics behind animation. Okay, if you write the spacing uniform, it is no acceleration motion. But actually here spacing is not same. Like this, it is non-uniform spacing. I told you why the diagram is like this, because there is not enough space. I wrote it like this. But you should remember, this is not uniform spacing. Okay, from here to here, okay, you can take head to head reference or head to head reference or leg to leg reference. I take this as the total distance 0.4 or I take it as 0.5. Any number you can take, it is not an issue. Or okay, let me, for the sake of simplification, I take it as 0.9 only, so that I can go ahead with the calculation, right? It not necessarily 0.9 anything. Assume that the girl is jumping through 900 centimeter, almost 1 meter she is jumping. Okay, now base distance, that is distance between first to 2 frames. Base distance, according to this formula, total distance 0.9 divided by last frame is the number 4 minus 1 whole square. It is again 0.1 meter only. That is why I took it as 0.9, dear students. Don't think that I am just repeating the calculation. Since I am not using calculator, just if I get some other numbers, it may take time. That's why I am doing like this. But you can change. Even a 0.9, but you can take it as 0.4. You can take it as 1.2 and go ahead. Nothing will happen. Number, after all, it is a number. Okay, back to this. I have base value, that is 0.1 meter. Next, frame 1 to 2, it is equal to base distance into year to year, the multiplier is 1, so it is 0.1 only. Next, frame 2 to 3, that is from here to here, multiplier is 3, that is odd number, it is equal to 0.3. Next frame 3 to 4, multiplier is 5, that is F3 to F4 distance, 0.1 into 5, it is 0.5. Okay, now take total is 0.9 meter, it is nothing but a total distance through which she jumped. Okay, so this is the odd rule scenario number 3, and same thing you can apply even for fourth one also. Fourth one, jump down, jump up, jump down. So this ulta, reverse. Okay, initially she is here. Okay, then she will come to this position, right? Then she will come to this position, then she will come to this position. So frame number 4, frame number 3, frame number 2, frame number 1. Once again, dear students, remember the spacing is not uniform. Just I give you initial to final position value. I give you this time the value as, let us say, 1.8 I will give you, 1.8, right? Then totally 4 frames. Now you calculate the base distance. It is 1.8 divided by 4 minus 1 whole square. 1.8 by 4.1 whole square means 9. So base distance is 0.2 meter. Got it? Now you calculate the distance from F4 to F3, F3 to F2, F2 to F1. So F4 to F3 distance is equal to base distance 0.2. What is the multiplier? Yes, you are correct, it is 5. Next to 3, next it is 1. So it is 0.2 into 1, it is 1.0. Next F3 to F2, it is base distance into multiplier is 3, that is 0.6. And next F2 to F1, that is 0.2 into multiplier is 1, that is 0.2. Total it 8, 1.8, that is the total distance. So like this we can discuss any cases. Just I have taken only 4 scenarios: slow out, slow in, jump up, jump down. Okay, in all the cases what I did initially, I calculated the base distance, and then I calculated the frame to frame distance, and then I calculated the total distance. Okay, total distance is already given, I just cross verified it. I hope you got it. Slow out, slow in, jump up, jump down. Okay na? So dear students, I will stop this video now. I will continue with the last part of this one, that is examples for animation. Okay, examples for character animation. Okay, so I take up that after this video. Thank you very much.